Today we're going to be graphing the polynomial function f of x equals 2 times x minus 1 squared times x plus 1 squared. So to start, the degree of the function is 4 because this 0 is squared and this 0 is squared, and 2 plus 2 is 4. The number of solutions is also 4 due to the FTA, which says that any polynomial function of degree n will have exactly n solutions. The amount of turning points, n minus 1, which is 4 minus 1, so we have 3. Our n behaviors are rise to the right and rise to the left, because this is an even degree function. Our absolute min will be at our two zeros, -1 and 1. Our y-intercept, which we find by making x 0, is 0 and the y-intercept at 2. Now that we have enough information to graph, we're going to go ahead and graph our function. And now I'm going to explain why I went this way in the graph. So the 0, -1 has a multiplicity of 2, which means we bounce. And the 0, +1 also has a multiplicity of 2, and we also bounce. So we're going to fill in our zeros. Since 2 is even, we bounce, but if it was odd, we would go through. Since this is an even function, it has symmetry in respect to the y-axis. So just like we bounced here, instead we're going to go through the y-intercept. Now our intervals of increasing and decreasing, we say by the values on the x-axis. So it's increasing right here, it starts increasing here. So we're going to say it's increasing from -1 to 0, the x value of this point. And it's also increasing from this point to infinity. So we're going to say union as well as 1 to positive infinity. And the decreasing, we're going to do the same thing, but where it's decreasing. So we start at -infinity on the x value. And it stops decreasing at -1. And it's also decreasing from this x value 0 to our next 0. Our relative max also happens to be our y-intercept, which we already figured out by making x 0. So relative max is going to be 0, 2. And that's our polynomial function.